I want to focus today on the European Union field guide to how to managing complexity and chaos. It's actually a general field guide to how to managing complexity anyway, but it was brought on by COVID. So what I want to do is to set the context to explain why we did that, talk through what are really three of the key things that companies need to be doing, and IT departments in particular need to be supporting, not only to manage the exit from the current crisis, but also to actually start to anticipate for future ones. And just to be depressing here, I sit on enough think tanks to know that the sort of stuff we've been through over the last 18 months is not going to stop. It's going to come backwards and forwards in waves for several decades to come. So there's a degree to which we need to prepare our organizations, our countries, our societies to handle a more regular sort of phase shift in disruption over time. And technology has a huge role to play in that. Either way, to give the context, some years ago, I did a series of presentations in Brussels to the European Union. That got them interested in complexity theory. We then got the adoption of the Cynefin framework, which I'm not going to go into today. There's enough material, including some in Ukrainian, I think, on that. But it led to the adoption of the Cynefin framework, which is a complexity-based model or framework to understand how to do governance in an increasingly difficult to understand in an increasingly complex world. So that was adopted. The design team within the European Union was assigned to it. I work with them. We produced some powerful materials to help in what is called sense making. And we were in the middle of that and about to go into a future release when COVID hit. And of course, that changed everything. I went from traveling, I think the last full year of travel, I did 252 days in hotels. So I went from that to no travel at all. In fact, I was saying to my wife the other day that we haven't been together for so long since university days. And the marriage has managed to survive being together for 18 months without any break. So that's not bad. Either way, everything changed. So we decided what we would do is to take that lessons learned and produce a field guide. And you normally write the theory book first, and then you do the field guide. So this is the other way around. The theory book is underway at the moment. And what we wanted to do was to make it fairly practical. So we wanted it to be clear what you should do. But we didn't want to compromise on complexity. Your conference is about making things simple, which is a good idea. But there's a very big difference in English between making things simple and making them simplistic. Yeah, the first is good and the second is bad. So we wanted to avoid compromising. I mean, it's in difficult times, you need to sometimes handle difficult concepts. And you need to adopt radical changes in practice. So we didn't want to compromise on that, but we wanted to give people a basic structure. So it took about 6 months. I was the primary author on content. Alessandro was from the EU was the editor and the designer, and you can download the handbook for free from the EU website, or you can buy a hard copy of it. So if you haven't got the link, we can supply those later. So it's a free asset. It's available worldwide. And there's also an assessment process to go with it, which is up on our website, in which it's able to go through very quickly with a company and assess what they've done, what they should do, what are the gaps, where should go next. So those sort of background materials are sort of coming. So the field guide itself talks about 4 basic stages that you go through when you hit a crisis: assess, adapt, accept, transcend. So I'll go through those at a high level and then talk about 3 core activities related to them. The assess process at the start is designed to basically say, what's the nature of the crisis? If this is a situation that we already have a contingency plan for, it's something we actually forecast, we have scenarios worked out for it, and we know what we should do, then it's not really a mega crisis. It may not be much fun, but we know what to do. The point where it's a dramatic crisis is where we're dealing with something which, even if we anticipated, we didn't really prepare for. And I think COVID is a good example of that. So that's kind of like a rapid process. The stuff I'll talk about later about using human sensor networks and mass engagement with the workforce makes that easier. But for the moment, that's a very simple question. Are we really in a crisis or not? Did we plan for this? What elements did we plan for? Should we implement contingency plans? So that's really 101 strategic management, to be honest. There's nothing special about that. The second step gets more significant, and that's the adapt. So you're in different circumstances, so you can't carry on as you were before. And that's where we have three core technology changes which need to take place. And I'll go through those in succession and give you some of the science before I finish off with the last two stages. So the first, and sorry, by the way, the argument is all of these three things you should already have done so that you can activate them in a crisis. If you haven't done them, you do them quickly because you need them, right? And then you just keep them going thereafter. So the three things are fairly simple. One is building informal networks or informal cross-silo networks. The second is mapping what you know so that you can radically repurpose it for changed circumstances. And the third is to build human sensor networks by which you can actually get real-time feedback from culturally, educationally, experientially diverse networks. So those are the three core activities. So I'll go through those in succession. The first one really comes from complexity theory. And complex adaptive systems theory it's a scientific approach. It's largely now starting to displace systems thinking. Systems thinking came out of cybernetics and systems dynamics and some other areas of work back in the 80s and 90s. In its popular forms, it's things like business process re-engineering, Six Sigma, Peter Senge's learning organization, and a significant amount of agile methodology really belongs within that group. Yeah? Complexity theory deals with systems which, sometimes known as the science of uncertainty. The science of systems where there is no predictable or repeatable relationship between cause and effect, where the same thing only happens again the same way twice by accident, by which there's constant variety. So we contrast those type of systems with highly ordered systems or structured systems. And the difference here, in an ordered system, you have a level of constraint, a level of control, which creates predictability in the system. In a complex system, you don't have that level of control. You could argue that actually, the thing is contained, right? First time I ever came to the Ukraine, actually, by the way, was on a UN project related to Chernobyl. So that sort of triggers the concept of containment, all right? You have to contain something. Within that containment, all sorts of bad things can be happening, but they won't break the boundaries. So ordered systems are highly contained, highly structured. The containment may be expertise, it may be education. So if you're right to have education and the right background, you may be authorized to make decisions. But if you don't have that education, if you don't have that background, you can't. Or it can be very simple ideas or clear ideas, like in the Ukraine, you drive on the right-hand side of the road. In Britain, we drive on the left. Those are examples of best practice. And an awful lot of software development fits within that domain, and quite legitimately. The complex domain, on the other hand, probably the best definition I've ever heard, and I'll need to translate this, I expect, is from Alicia Gerraro, a Cuban who's working with, who's been in the US ever since the revolution in Cuba. Brilliant woman. Wrote a book called Dynamics in Action, which is a classic of complexity theory. And she said a complex adaptive system is like bramble bushes in a thicket. So thicket is the English word for a small, dense woodland. Yeah. And bramble bushes are those long spines of things which seem to grow and produce wonderful fruit. but scratch you to hell when you try and walk through them. And that concept of entanglement, you've got a dense woodland with lots of undergrowth, no clear pathways. Everything is connected with everything else. And you know everything's connected, and you know these plants are actually separate, but you can't separate them. And if you pull on one, another one sort of snaps behind and hits you in the back of the neck. So the one thing we know for certain about a complex adaptive system is anything you do has unintended consequences. So the key concept of a complexity system is everything is connected with everything else. In an ordered system, everything is contained. In a complex system, everything is connected but not contained, which means you can have open connections, the system can be open to the outside, and so on and so forth. Now, it's important to understand that the way you manage complexity is by parallel safe-to-fail probes, by experimentation, because everything you do will change the space. This is Heisenberg's uncertainty principle. You can't look at the system without changing it. And that's what Cynefin was originally devised for, and I won't go through that in any more detail, just hold that one in mind. The key concept I'm picking up from entanglement is that actually entanglement has arisen in nature because it kind of like works. So if you want a metaphor for this, if you look at trees in ground, all right, so you've got trees, you've got tree roots, it's highly visible, it's fairly structured, the tree roots are quite dense, they all sort of flow out from each other in a hierarchical way. But the things which keep the trees healthy and the soil healthy are the fungal roots which connect the tree roots. And those fungal roots extend 500 times farther than the tree roots itself. And they have a symbiotic relationship with the trees. They provide it with water and nutrients, in return for which the tree provides the fungi with sucrose. So it's a symbiotic or a mutually beneficial relationship. And without that dense network, which you can't map, it's just too complex to map, it's just too entangled, the system isn't healthy. Now, the metaphor I'm moving on that is informal networks as against formal systems. So in all large organizations, who you know actually often matters more than the formal system. And a lot of people complain about this, but it's just life, right? It's like people complain about silos and say we need to break down silos. Well, people have been saying that and trying to do it ever since Xenon, the tyrant of Athens. I mean, this goes back about 6,000 or 8,000 years. So we ain't managed to fix it in that time. We're not going to fix it because actually silos are extremely useful for organizing structured or ordered knowledge. And formal systems, formal communication channels are designed around flowing specific types of information, and they're very powerful for doing that. But informal networks are actually what people use. When I did the original work on this in IBM, and there's a paper on this called Complex Acts of Knowing, which is the third paper on Cynefin, and you can get that on our website. One of the things I found is that the ratio between formal and informal communities in IBM, which is where I was working at the time, was 1 to 64. So for every formal community or formal structure, there were 64 informal communities. And those informal communities formed in a variety of ways. Some of them were cohort groups, people who joined the company at the same time, who went through induction training together. Another were project teams, people who'd been together on a difficult project. They'd come through the project, they were still there. They'd now moved on to other projects and other departments, but they still kept in touch and knew each other, and they could use those social networks. People who went to the same university, went to the same school. These are kind of like really important for human beings, and we create them all the time. And the thing about informal networks is they're effectively a context-free communication channel. The communication channel is evolved without specific information flows in mind, and therefore it's far more adaptive than a formal channel which has been designed for specific information flows. So in a crisis, people tend to fall back to the informal networks. And I've done over 100 interviews now at C-level in government and industry alike. And almost the universal thing when I've checked it is that the thing which really helped them was their informal networks, not their formal system. And most of them were fairly honest about it and basically said one of the reasons they were in their jobs is because they knew the right people at the right time. Now, I want to get pragmatic about this, and trying to get rid of that won't work. It just goes further other ground. But the idea is to make it more meritocratic. So to give you a government example, Singapore, which has had a very successful COVID crisis, partly because it had the sort of memory of SARS before it, but also because it has an extremely efficient and well-paid civil service, where the best and brightest go into government, not industry. But all of them have done national service. They've served in the Singapore Army or the Singapore Navy or the Singapore Air Force. And so they build their informal networks in the officers' mess, in the sergeants' mess, in their 1 week training every year for the next 5 or 6 years after they leave and so on. This builds deep relationships which they can fall back on in government, and can rely on. So that's a meritocratic informal network. The British government, on the other hand, and sorry, I hold no brief for the current government in Britain whatsoever. I think we're trying to out-Trump Trump in Britain at the moment. But basically, the informal networks come because people went to one of 2 or 3 very privileged elite schools and then went to 1 or 2 or 3 privileged elite universities. So their networks are actually very narrow. They're not meritocratic, they're actually plutocratic in terms of the way they work. So the first action, and there's a body of methods, and these are, if you don't know, we put all of our methods into an open source wiki about 6 months ago, and anybody's welcome to participate and use that material subject to the normal Creative Commons things. We developed a technique there called entangled trios. Now, we'd originally used this in software development. That was the first use of it, where we decided one of the big problems with software development was the manufacturing concept which underpinned most agile methods. The idea you have a sort of flow process, somebody defines what they want and you find more effective ways to deal with it. And I was particularly keen, and this is a lecture in its own right, I won't give it now, on identifying unarticulated needs. I've built 3 software businesses in my life, and the first one was built because I had been a financial executive and I was also a computer programmer. So I knew what people actually needed, not what they said they needed. And that got me promoted and built a successful business and so on. So to come back to this, so we started to focus on a series of methods to improve the feed into the backlog on, for example, Scrum. And one of the methods we developed there was to take a very young programmer, somebody straight out of college, very bright, very fast, very naive, put them together with somebody much more experienced, a systems architect or a systems tester. Testers don't get involved in design frequently enough, in my view. So somebody young and naive, old and experienced. And then the third from the IT department. And then the third person was a user trained to talk to IT people. And what we've actually discovered is that it's easier to train users to talk to IT people than train IT people to understand users. And there are all sorts of cognitive neuroscience reasons for that, which I can go into later if you want. But basically what we do is we take those 3s, and we might have 15 or 20 of those trios, and we throw them at a problem area for 2 or 3 weeks and see what they came up with. And what we were doing was increasing the diversity in the system. But what we found as a side benefit of this is those networks started to become quite powerful as people linked and connected. So we started to do it with new joiners, with people about to retire, with the third person being somebody from management. And we use that for innovation. So that, young and bright, old about to retire, not playing politics so much anymore, together with a political actor, 15 or 16 of those trios working found really innovative solutions. And we did the same in industrial redevelopment in South Wales, where we got young kids, and about 16 or 17-year-old, with people from their grandparents' generation in groups of 3, where the third player was somebody from government who could make their ideas happen. And that proved a transforming process overall. So that's now been further developed, written up and controlled. So you run people in small groups of 3 from different backgrounds on 2 or 3 month part-time projects continuously. There's always something that you need those sort of networks to run. And you keep switching the membership of the trios on a 6 month or slightly more or slightly less cycle. And that actually means within a year, everybody, if you design it properly, and we've done all the work on the background on this, within a year, everybody is within 3 degrees of separation of everybody else within the network. And that means what you've done is you've built that fungal root system to connect the formal systems. And that system will actually is arisen through acting together, not by talking about what we want to do, but by doing things together. And therefore it can handle complete novelty because it's a context-free information system. So that's kind of like number one. And like most things in complexity theory, you do something with one main function, but it has all sorts of side benefits as well. The second one is links with a process in biology, which is called acceptation, or radical repurposing, to use the language I used earlier. So I'll give you the classic examples on that. So we now know that all dinosaurs had feathers. This comes from discoveries in northern China, and the feathers were actually quite colourful. So the thesis is that those feathers developed for warmth or sexual display. And then we find one small breed of dinosaur which actually runs very quickly. It's small and fast, it has to escape predators. And it develops skin flaps under its forelimbs. And the obvious evolutionary reason for that is to better display those feathers for sexual purposes, rather like a peacock's tail. But then when they run, they put out their forelimbs, and because of the skin flaps, they start to glide. And that's actually how we get flight. So acceptation is a trait which evolves in a linear way. It adapts in a linear way for one function. Under conditions of stress, accepts for something completely different. Now, another example is a cerebellum at the base of your brain, which evolved in higher apes to do fine-grained manipulation of muscles in fingers so that we could pick seeds from seed pods and make tools and all those cool things. And again, that's a linear adaptation. But then it accepts in humans to actually manage grammar in language. Grammar is far too sophisticated to have evolved in a linear way. It required this non-linear repurposing. And if you think none of this is relevant to industry, well, in 1945, a Raytheon engineer maintaining the magneto of a radar machine noticed that a chocolate bar melted in his pocket. Now, he wasn't the first person to notice this. Several people had done it, and they swore and got their trousers cleaned. He realized the significance, put a metal box around the magneto, and we got microwave ovens. And if you look at the work of Brian Arthur and others, you'll find that most technology innovation has actually been acceptive, not linear. And of course, there's a famous case of one scientist reporting an embarrassing side effect of a cardiac developed drug to another one, and from that Pfizer got Viagra. And I can give you lots of other examples of this. Fundamentally, it turns out that this radical repurpose in acceptation is key. Now, I'm part of a group of academics who meet and look at this subject every year or so. It's quite a fun event, actually. We're in Lake Garda, in Mussolini's former palace on the lake, which is the Milan Business School's conference center. So I deserve no sympathy for enjoying myself there for a week, having good conversations. But one of the things we've been doing is working out the conditions under which acceptation happens. How do you create the biological conditions and therefore the sociological conditions under which ideas will leap sideways into novel purposes? And key to that is the concept of granularity, of getting things at the right level of granularity. So the radar machine is too coarse, the components of the magneto are too fine, the magneto is just right. So it's really important in any organization to do what's called knowledge mapping. But knowledge mapping is done by, first of all, producing a decision information map. So you basically, and we do this using journaling software, so people diarize their decisions over time. and they diarize the information flows around those decisions. And from that, we draw maps which look like spiders' webs. Yeah. And we then contrast those with the formal system, and they're never the same. They represent the way the thing actually works, as opposed to the way it's been designed to be worked. And then within that context, we can extract from those decisions the knowledge that people use. And that knowledge this is a mnemonic, it can be artifacts, things which are man-made. Those can be things like computer models, as well as tools. They can be skills that people can be trained to acquire. They can be heuristics or rules of thumb. Most experts develop a very high level of heuristic use. It's one of the most effective ways of storing knowledge management. Some of it is experience-based. There are some things you just can't do without 4 or 5 years of experience. And of course, finally, there's natural talent. Some people are just really good at doing some things and other people never will be. Some of that's actually, the sort of nurture you get. I mean, if you don't get the right type of family care before you're 5, you'll never be able to fly an airplane, for example, because the right sort of development doesn't actually take place, the key point in brain plasticity. But that sort of concept is called ASHEN, artifacts, skills, heuristic, experience, and natural talent. That map of knowledge, which is an unstructured map, we actually hold this using what's called high abstraction metadata, which is a non-categorization approach to metadata that we developed working on counterterrorism in the States 20 years ago. And we hold it at that level so that we can then effectively bring together completely novel needs with existing knowledge and existing artifacts and find new ways of doing things very quickly, because we don't have to invent from scratch. And that approach is also part of a general approach to design thinking, in which you map existing knowledge against unarticulated needs. And that's how you really innovate, and that's actually how you do the sort of incubator type approach of getting academic ideas into industry or entrepreneurial startup, and there's work going on in those areas as well. So the second big activity is to get what you know mapped at a level of granularity so you can repurpose quickly in a crisis. And then the third thing is to build human sensor networks. Now, another bit of science here. If you take a group of radiologists, and these are highly trained individuals, and you give them a batch of X-rays and ask them to spot anomalies, and on the final X-ray you put a picture of a gorilla which is 48 times the size of a cancer nodule, then on average 83% of the radiologists will not see the gorilla even though their eyes physically scan it. And the 17% who do see it come to believe they were wrong when they talk with the 83% who didn't. This is called inattentional blindness. And in overall, it has evolutionary advantage. The most anybody in the audience will scan of available data is about 3 or 4%. There's a theoretical max, I think, of about 5%. Most of the time, we're 2 or 3. That then triggers a series of memories in our brain and our body. It's not just the brain. Some of those are recall memories. Some of those are as a result of education or training. But they're fragmented. And then we blend those together. It's called conceptual blending in the literature into patterns. And the first pattern of memories which works, we apply. That's how we make decisions. Yeah? It's not the best pattern. It's the first pattern which works. I would say in evolutionary terms, you can see why this happens. If you think about the early hominoids on the savannas of Africa, something large and yellow with very sharp teeth runs towards you at high speed. You don't want to autistically scan all available data, look up a catalogue of the flora and fauna of the African veldt, and having identified lion, look at best practice case studies on how to avoid lions. By that time, the only document of any use to you will be the book of Jonah from the Old Testament, which is the only example I've found of a manual on how to escape from the digestive tract of a large carnivore. So we evolved to make decisions very, very quickly based on a partial data scan privileged in our most recent experience. And most of the time that works well. But it doesn't help for innovation. So we call this finding the 17%. And the way this works, we're about to launch something in September, which will be a chance for people to play with this for free as well, is you get people on an app-based environment continuously capturing anomalies and ideas and concepts, and then you can present something to that whole group in real time. This is a wisdom of crowds approach. They can then interpret that in common, and from that we can draw what are called fitness landscapes in complexity, which look like contour maps. So where the contours are dense and close together, that means there's a strong correspondence there. There's a strong common opinion. But it also shows outliers and weak opinions. So from that, as a senior executive, I can look at that map and see where there's consensus and where there isn't. But critically, I can find outlier groups, people who are looking at the problem differently, people who have seen things that other people haven't. Now, that's something you can roll out within a couple of hours to a whole workforce. And that means your workforce becomes a decision support tool to support the executives. And in a crisis, you need that ability to look at things from many perspectives in real time. You haven't got time for traditional consultation. So building and practicing and using human sensor networks actually has high utility anyway, but it's absolutely critical in a crisis. So the three core things that we need to do is, one is actually build informal networks. Secondly, map what we know for radical repurposing. And third, build human sensor networks. The good news is these have operational use on a regular basis and actually are key to the future of things like Agile. But in a crisis, they really come into their own and they can be used in very different ways. Which kind of like leads me to a couple of final points I want to make, and then I'm starting to get to the point where I'll leave time for any questions. The first one is, in a crisis, you actually coordinate in the center, you distribute decision making. In fact, I'd argue generally that's what you should do. If you're a C-level executive, and I've been one for a lot of my career, you don't get much time to make decisions. I mean, you're sat at your desk and there's 5 groups of people sat around the table, which is joined to your desk, or on Zoom these days, and they're all deep experts and they've all researched the subject and they've all got highly developed opinions. They have knowledge you haven't got, and you've got to make a decision between all of them, and you might get 5 or 10 minutes. Now, that's almost impossible. And as I say, there are 3 approaches to this. One is this concept of parallel safe-to-fail experiments. You allow anybody with a coherent idea to go and play for a month and see what happens. That gives you breathing space. There's another one called a triopticon, which is a formal method within the wiki, and people are welcome to look at that and read it. It's got animation and everything. That's effectively a sort of staged form of dispute between experts, which allows the executive to look on and then make a decision. So those are kind of like 2 formal methods on this. But actually, we can also use the sensor network, because I can actually ask my whole workforce and present ideas to them, look at how those are mapped, and from that make a decision. The entangled trios also helps on that, and we are actually organizing their own company based on 3s and 5s at the moment. And basically, if 3 people agree on something, they have the authority to make a decision. So that way we can actually remove executives from decision making, and we can create a much more distributed and fluid approach. That's been written up at the moment, but there's stuff in the wiki as well. So that concept of centralized, coordination from the center, distributed decision making is key, unless you're in a mega crisis, at which point you have to make decisions to hold options open for longer. The New Zealand Prime Minister did this really well, actually. She broke the law to actually lock down New Zealand. Now, she didn't know that was the right or wrong thing to do, but it was the thing which gave her more options for the future. And that's what crisis-level decision-making is about. And again, it's something we're now starting to do post-COVID with companies, is go through what's called anthro simulation, which is a highly sophisticated game environment with human actors rather than machine algorithms, which actually takes people into, in sometimes fictional settings, to develop those sort of skills and those sorts of abilities. Yeah, so we get some of the benefits of hindsight coming into that, but we need to create that intuitive ability to see those patterns. So, hold the options open, don't make decisions. And this is how you actually test for leadership, by the way. Somebody who makes decisions now which keep more options open for the future is better than somebody who just happened to be right the last time you recorded them doing something. Options are key here. The second one, which I've already referenced, is effectively communicate by engagement. There's nothing worse in a crisis for your employees than to be told things intermittently when you've got time. What you actually want, and that's what we use the human sensor networks for, is this is the situation, everybody got opinions. This is the problem we got, anybody got ideas. So you're continuously gathering stuff from your workforce in real time, and then your communication department feed back to them using those particular processes. So what we're doing here overall, and as I said, there's a lot more in the field guide than this, and a lot more methods, and those link in with the Cynefin.io, which is where the wiki is basically saying you need to be able to take an approach which puts different things together in different contexts. And this is the big shift that we're seeing in management science from an attempt to define a solution to cover everything. Like Scrum or SAFe or Six Sigma or Blue Ocean or learning organization or design thinking. All of these approaches have claimed to be a universal. What we're now moving is away from that into something which is more finely grained and context specific. So basically I can take something like Scrum and break it down into a series of separate methods. I can then recombine those methods with other methods from other frameworks, and I get far more flexibility in terms of the way I work. And the same is true at an organizational level. So it's this ability to understand and use context, which is actually key. So I've summarized the sort of key aspects of the field guide. Remember I said assess, adapt, exact, transcend. Well, I started with assess and adapt, and I've effectively done exact. That's the repurposing. Transcend comes at the end. The worst thing you can ever do in an organization is try and do a massive cultural change project or a transcendental project. So I'm being a bit sarcastic there. Anything which claims to change the organization radically generally doesn't work. People have become sensitized to it. Transformation actually comes at the end of doing things, not at the start. And I want to leave you with one sort of enigmatic question to think about. The Northern European, North American tradition has always been a sort of talk then do. So we all sit around and we talk about things and we set targets. We agree what we'd like to be. We agree on culture, on principles and stuff like that. And then we try and make it happen. The tradition in other areas, Africa, Asia, the indigenous work I've done in Australia and elsewhere, is let's start and do things together and then have the conversations. Because if we do things together, we'll understand things more. And to give you an example from the work I did in peace and reconciliation in Ireland in the 70s, instead of getting people to sit together and talk about the problem and say how they would stop fighting each other, which they would all do in a workshop, but within weeks they'd be fighting again, we took people from both communities in small groups. This was actually another example of 3s and 5s, and dumped them into Latin America to actually work on urban redevelopment projects in slum areas. Yeah. So in slum areas, all right? And the basic principle of that is they then had a conversation about their religious differences while they were working together, because they discovered they had more in common. So that was the final point I wanted to make, which is basically switch from talking in order to act into acting within a scaffolding, within an architecture, within a structure, and then allow the conversations about the future.
I don't know how to respond to that.
Sorry, that was Siri then. So with that, I finished.